All right. So this is the problem where you have to prove that something is conservative and find the function equation. Um, so I'm definitely sure that a problem like this will be on the exam. So this is quiz 7. Quiz 7, number 2. Number 3, actually. Okay. So the thing about Calc 3 is that you have to essentially memorize a lot of stuff. The actual math, like doing integrals and derivatives and stuff, is essentially the same. You didn't learn anything new about that. It's just knowing the equations, say for flux and all of that stuff, right? That's the tough part. So for this, what are the three, or yeah, essentially the three comparisons we need to make? For the first one, we have dm, partial of m with respect to y, right? What does that have to be equal to? Partial of n with respect to x. So our m is always in front of the I component, our n is in front of the j component, and our p is in front of the k component, right? So what is the partial of m with respect to y?
2yz cosine.
Right? The partial of n with respect to x?
2yz cosine x.
It's the same. So we know this is true. Next is partial of n with respect to z. What does that have to be equal to?
Partial of p with respect to y.
You can write that in the middle and then set it equal to the next thing, whichever. So what is partial of n with respect to z?
Y squared cosine
2y sine of x plus 2z, right? And what is partial of p with respect to y? The same thing. Yep. So we know this is equal. And the last one is partial of m with respect to z equal to what? Partial of p with respect to x. And what is that equal to? Yep. So then we know that the vector f is conservative. So you do need to know what these three are, but essentially it's just different combinations. The one thing that I always memorize is that m is always across from partial with respect to x, right? So if I put m with respect to y underneath it, then I know n has to go on top because n is similar to y. You guys all realize that pattern? Okay, good. We'll move on then. So now we have to find f such that the gradient of f is equal to the f vector. Because of that, we know that the partial of f with respect to x has to be equal to what? M. And m is what? We have up there. Y squared z cosine of x. right? So if we wanted to find f, we do the integral, yeah, with respect to x, right? So what is the integral of this with respect to x?
Y squared z sine x.
Yep. Plus g of y comma z, because f is a function of x, y, and z. So we still need a component with y and z. So you bring this to this side essentially and do the integral. Next is partial of f with respect to y. That is equal to what? N. So then we know that, well, first of all, we can just write partial of f with respect to y. What is the part? What is that?
2yz sine
2yz sine of x plus partial of g with respect to y, right? And we set it equal to n, which we know n from up there. 2yz sine of x plus z squared. We simplify that. So then we find g, we do the integral of this with respect to y. So then f of x comma y comma z is equal to y squared z sine of x plus what? Yz squared, because we're taking the integral of z squared with respect to y, and since there's no y, it's just yz squared. But then we now have to add h of z. So then, this is not necessarily, I don't know, they wrote it here, so I'll just write it here. G of y comma z is equal to y z squared plus h of z. Do you guys have this copy down? Yeah? Where's the sign sheet? There's one here. And where's the other one? Over there? Okay. You guys can just pass that one across, and you can pass that one to the back row. Make sure everyone signs. Yep. So the last part is taking the derivative of f with respect to z, and that is equal to what? P. So we take the derivative of f with respect to z, and what do we get? Y squared sine of x plus 2yz plus h sine of x. We can write it. Yeah, sorry, h sine of x equal to p, which is up here, y squared sine of x plus 2yz plus 3z squared. So then these two parts cancel out. We take the integral with respect to z. So then h of x, or h of z, is equal to z cubed plus c. So then at the end, this is equal to all of that plus z cubed plus c. So this is your answer for the function. Any questions on that? So the last part is doing the integral of f dotted with dr, going from 0, 0, 0 to pi over 2, 1, 1. But we know that this is equal to what? Just f of x, y, and z. So then we plug in the values as limits. Okay. So then here we have 1. So if we plug in pi over 2 sine of x, what do we get? 1. So we have 1 plus 1 plus 1 for plugging this into the entire function, minus 0. So our answer is 3. Any questions on this? No? Are you guys done copying this? Yeah. So I know like that problem is definitely going to be on the exam, I feel like. It's one of those basic problems. I have other problems like the divergence theorem, and I can go over that. Is that fine? Essentially, I feel like it's always just memorizing what little equivalences. Yeah.
Stuff in the version is gonna be on there.
Yeah.
Yeah.
Well,
Like the memorization perspectives.
yeah. They told me that they covered that in class. That's why, or did they not? No? Didn't do that?
There's a whole, like, in one of the driving notes for unit 1, they do all of it for one job.
Here's the first quiz.
So the problem with the K, N, B, and all of that, is that what you guys are talking about? Do you want me to do one of them?
Yep.
Okay, we'll do that.
As long as it's gonna get up to them.
Yeah, that's,
It's like the main.
I feel like that's, yeah. What I remember from my Calc 3 exam is that they tested us on like a bunch of topics, but like didn't even touch some topics.
There was no
Like-
space math, right?
Oh,
What?
There's no space math, right? I was gonna ignore the space math.
What's the space?
Like, the apogee and the perigee.
No, I don't think so.
Okay. It was
Like they covered divergence and Green's theorem for sure, but then there were other parts of the unit, like you know how in Calc 1 and Calc 2 they essentially go through every single topic on the exam. Like you definitely need to know it all. For Calc 3, they just skip like some aspects of it. But I feel like this problem should be on there though. Let's do this one with what you guys were asking. Okay, so we have the, okay, this is exam 1. Problem number 6. Okay. So we have the vector r with respect to time, 2t squared I plus 3 times t cosine of t minus sine of t j plus 3 times the quantity of t sine of t plus cosine of t k while t is greater than 0. So the first part, they ask us to find velocity with respect to time. And what is that essentially?
It's the derivative.
It's the derivative. So 4ti plus 3 negative t sine of t plus cosine of t minus cosine of t plus 3, so j right here, plus 3 times t cosine of t plus sine of t minus sine of t. Okay. So those cancel. I don't have this problem here, but do you guys remember the whole optimization problem and stuff?
The box.
Yeah. Remember to study that.
Thanks, man.
Yeah.
Way to be there.
That will like for sure be on the exam. Okay. So part B, any questions on this? That's just a derivative. Part B is the magnitude of velocity. That's the square root of each component squared. So 4t squared is 16t squared plus what do that? So we square that. I don't know what they have here.
They did 9t squared.
They combined it.
and then
Yeah.
9.
So this is 9t squared sine of t plus 9t squared cosine of t. Okay. Sine squared. Cosine squared. So then these two combined, we get 9t squared, the quantity of sine squared t plus cosine squared t. We know that that is equal to a 1. These two combined, we get the square root of 25t squared, which is equal to 5 times the absolute value of t, which is equal to 5t, since t is greater than 0. And I am sure you need to write this in. Any questions on that? No? Then part C is finding the tangential. Do you guys know what that's called? The t vector.
Tangent vector.
The unit tangential vector. Okay. That is equal to what? Do you guys remember what it is equal to? Yep. So you guys need to memorize all of that. The v vector divided by the magnitude of v vector. So it's the unit tangential vector, I guess. So that is equal to, we know that it's the, essentially, we are dividing by 5t all of the part A So we know we can take out a t in every single part, right? So we can just write 1/5 times 4i plus or minus 3 sine of t j plus 3 cosine of t. Okay. Okay. Part D is the derivative of that with respect to time. So then you guys know how to do that easily. That's 1/5. We know the derivative of 4i is 0. Minus 3 cosine of t j minus 3 sine of t. Okay. Right? And we can take the 3's out too. So this is equal to minus 3 over 5 cosine of tj plus sine of t k. Again, the big thing, well, not again, but the big thing about these is time. You don't have much time on the exam, so you do need to go.
They're gonna secretly give us your time.
A lot more time. 7:45.
The exam is at 7:45 in the morning.
Yeah, 7:45 to like.
It's supposed to be 8, but like they
Yeah.
want to show us so we can see it.
That's really early. Okay. Do you guys have this copied down? Yeah. Part E is finding the derivative of t with respect to s. All right, guys. Oh, lowercase. What is this equal to?
T divided by the magnitude without it.
Yep. So if we break it down, it's the derivative of t divided by time all over ds divided by dt. The t's cancel out, so that's equal to our original. So then we know this is just equal to dt divided by time all over the magnitude of velocity. Okay. So then this is equal to what we found in part D divided by 5t. So it's -3 over 25t times cosine of t j plus sine of t k. What we found in D divided by 5t. So yeah. Okay. Part K is the magnitude of that. So that's always the absolute value of the term on the outside times square root of cosine squared t. Yep. So we know this is just going to be 1 inside the square root. So this is equal to 3 over 25t. Any questions on that? Part F is finding k, which is equal to, we just found k. Part G, did I not label it? That was F, So now we have G. That's finding the normal vector, which is equal to dt divided by ds divided by the magnitude of dt divided by ds. Is that right? Not the capital T. Is it the capital T? Yeah, okay. So we are essentially dividing these two. So what do we end up with? Yep, negative the quantity of cosine of t, j plus sine of t. Okay. The next part is finding b. What is b equal to? Do you guys remember? T cross n. So we have I, J, K. Okay. So we don't have our T up here, but that was 4/5 right here. Minus 3/5 sine of T. Minus 3/5 cosine of T. 0 minus cosine of T minus sine of T. Okay. So then our I component is equal to the cross product, or whatever you might call it. So the component here times the component in the lower right corner minus the other part. So we have 3/5 sine squared t plus 3/5 cosine squared t minus the j component, which is negative 4/5 sine of t minus 0 plus the k component, which is negative 4/5 cosine of t minus 0. Okay.
Our T value, we had a positive 3/5 cosine T.
Right here. Was it positive? It is positive. It doesn't change anything though. I just wrote a negative here by mistake. So this is still right, I believe. So any questions on how to do this? The matrices? No? Again, this all, when I'm writing it up here, it seems really basic, but if you guys have questions, just ask. So you can simplify that. I don't want to write that out.
They're gonna make us memorize all that, right?
Yeah. So that's the major thing about Calc 3. You just have to go through each exam, make a list of all the things you need to memorize, and do it.
Hey Danielle?
Yeah.
Do you have that list of everything to me? And can you post it for us?
No, of course I don't have it memorized. A lot of the later stuff, they are in the reviews that I posted, starting from unit 4 or 5. The other part, I think you just have to look at the old exams and write it down. So I don't have a list that I can just post. Essentially, you forget all of this the day you walk out of the exam.
I think we do that a lot.
Yep. For I, we have the derivative of b with respect to time, and I'll just write it out. That's 1/5 times 0I plus 4 cosine of t j plus 4 sine of t k. For j, you have to find the derivative of b with respect to s. That is equal to the derivative of b with respect to time divided by the magnitude of velocity, like before with the t. The magnitude of velocity was 5t. So in this, we have 4 over 25t times the quantity of cosine of t j plus sine of t k. Now we have to find, I think they call it tau. Do you guys remember what that is equal to?
Then dvdx also be
Yep. That is equal to. Do you guys want me to write it out or just give you the answer?
I feel like we get the point.
Okay, good. So in the end, it becomes to be 4 over 25t. Okay. So in class, they probably covered that whole partial derivatives thing, right? Like f of x plus f of y, plus all of that. We did, yeah, like those problems. Okay.
Unit 2. We did some unit 2.
We did one with the chain rule.
With the what?
We did some partials today.
Like with the constraints.
Yeah,
Yeah.
We did that.
that will be on the exam. Most likely.
Thank you.
Yep. All right, guys. For L, they gave us.
This is for L.
Yep.
Oh my god.
So we have to find for part A x of pi over 2, y of pi over 2, z of pi over 2. Okay. X of pi over 2 comes out to be, guys, calm down. Yep. It comes out to be pi squared over 2. Y of pi over 2 comes out to be -3. Z of pi over 2 comes out to be 3 pi over 2. So then we have to find t of pi over 2. That comes out to be 4/5 I minus 3/5 j plus 0k. Okay. So then we have to find the equation of the normal plane, but we know that these components are equivalent to ai plus bj plus ck. Okay. And the equation of a plane is always a times x minus x naught plus b times y minus y naught plus c times z minus z naught equal to 0. All the way from Calc 1. I think this was Calc. Was this Calc 2? It was the very beginning of Calc 2. Yes, it was. Okay. A is 4/5. So then we have x minus pi squared over 2. B is negative 3/5. So then we have y. Y naught is negative 3, so y plus 3. And then we have 0 for the k component, and we set this equal to a 0. When we solve it out, we get 4x minus 3y equal to 2 pi squared plus 9. Okay? And we're not done yet with this problem. You guys have this copy? No. We still have to find a tangential and a normal. Yep. Yeah. Don't quote me on this, but so you guys should definitely study this topic, but I doubt they'll have one of those math problems there. The math one. Finding mass, Rx, IV.
We won't have one? Wait.
I doubt they will have one. Did they go over it in class?
Yes. And, you know,
I don't remember having them on my exam, but they might, do it since they went over in class.
we talk about the triple.
The ones where it's like finding M, MX, and all of those. But if they went over in class, then you should definitely look over them. Because I don't remember them being on my final. But if they did it in class, look over them. So the last part is finding a sub t and a sub n. A sub t is equal to what?
Derivative of the magnitude of the velocity.
D squared over dt squared, which is equal to d over dt of the magnitude velocity. And that's equal to d over dt of 5t. That is equal to a 5. And what is the formula for the normal acceleration?
Square root of magnitude.
Divided by rho squared, which is equal to 1 over k.
K is 1 over row.
I don't know why they square it though.
There's 2.
Yeah, okay. So the magnitude of velocity squared divided by rho. Rho is always, or in this case, in these problems, 1 over k. So then we have 5t quantity squared divided by 25t divided by 3. Okay. So this is equal to 25t squared times 3 divided by 25t. So this is equal to 3t. And that's the answer for that. Any questions on this problem?
We have to memorize the problems.
Yeah. can okay. So there's this one other problem that I also want to do. It's the one where you have to find the center of the circle of curvature and find the equation like that, right? We should definitely go over that. So this is number 4 in exam 1.
Yeah, I put plus
Y is equal to -2 over x. So what is y prime equal to? Let's see. Did you guys say 4? 2 over x squared, yeah.
That's my fault, I said that.
Y double prime is equal to 4 over x cubed. So y of -1 is equal to +2. Y prime of -1 is equal to a 2. Y double prime of a -1 is +4. Then we have to find k, and you do need to know the formula for k. At x is equal to 1, k is equal to what? Y double prime, the magnitude of that, of 1 plus the quantity of y prime of -1 squared, and that entire denominator to 4/3. 3/2. Sorry. Okay. So that you do need to memorize. So we have 4 divided by 1 plus 2 squared to the 3/2. This is equal to a 5 on the inside. So we have 4 over 5 square root of 5. Okay. Then we also need to find rho, which is 1 over k. So then what is that equal to?
5 square root of 5
Over 4. Okay. Are you guys good with this? Okay, so we have to find the center of the circle of curvature with c h sub k. What is the equation that we use? Plus b sub t. And if you don't understand that, I will explain that. So we have the graph. So they gave us this graph, right? We draw a circle where the dot is, that's where the circle touches it. And we have the center of the circle with the center h comma k. The vector coming from the origin going to the center is OC. The vector going to OP, going to the point where it touches is OP. And the vector going from P to C is PC. So then we get the equation OC is equal to OP plus PC. You guys all see that? So that's how you get the three components. Now this is equal to, we know the point P already, and that was -1, 2. So then when we do the origin minus the origin to the point P, we do final minus initial. So we have -1 minus 0 I plus 2 minus 0 J. Okay? Do you guys see that? Final minus initial, the point -1 minus 0, 2 minus 0. Now this one thing that you do need to know, the formula for the vector PC is equal to what? Rho n. Okay? So now we need to find that. So that is done by knowing that MT, let me see if they ask you for that. Or they just, so they expect you to find all these things. So what is MT equal to? Y prime of -1, which is equal to 2. Or M sub n is equal to -1 over MT. So this is equal to -1/2. The formula for the n vector is equal to what? Plus or minus I plus m n j divided by the magnitude of 1 plus mn squared. Okay. So is it going to be positive or negative? Negative. Why is it going to be negative? Because the vector is pointing to the left. Okay. So from here it's pointing to the left towards the center. So that's -I plus 1/2 j divided by the square root of 1 plus -1/2 squared. Okay. So this is 1 plus 1/4, so it's 5/4 in the denominator. So -I plus 1/2 j divided by the square root of 5/4, which is the square root of 5 divided by 2, right? Which is the same thing as multiplying 2 to the top. So this is equal to -2I plus j divided by the square root of 5. Okay. So going back to our very top equation, the vector going from the origin to C is what? H minus 0 I plus K minus 0 J, right? That's equal to, simplifying the vector OP, we have minus I plus 2J plus now rho times that n vector. N was what? 5 square root of 5 over 4. So plus 5 square root of 5 over 4 times what we found for n, which is minus 2I plus j divided by square root of 5. Okay? So we can simplify this. The square root of 5's go away. So therefore, hi plus kj is equal to -1 from here minus 10 over 4 or 5 halves plus 2 plus 5 over 4. So -1 minus 5 halves is -7 halves. I plus 2 plus 5 fourths is 13 over 4. Okay. Okay. So equating the common terms, our h is -7 halves, and our k is 13 over 4. So then our center is -7 halves, comma 13 over 4. Okay. And they also want us to find the equation of the circle, which is x minus h quantity squared plus y minus k quantity squared equal to rho squared. So the equation will be x plus 7 halves quantity squared plus y minus 13 over 4 quantity squared equal to rho squared. Rho was 5 square root of 5 over 4. So if we square this quantity, we get 125 over 16. So any questions on this problem? Like, it has a logical order that goes through it, and then once you realize that, it's not that hard. How we got rho? We got rho by finding k before. By finding k in the first part. K. And then rho is 1 over k. Any questions on this problem? No? Do you guys have any other dire requests? Yeah. Do you guys have any other requests, or I can do a divergence problem?
Is that like a community?
That's the one with the where you have to do the. We can do one of those problems where you have to do the Stokes theorem with the walking around the surface thing. You guys got that? What? Yeah. With the that was the last unit, right? Yeah.
The stuff with percent error thing on there. The partials and then we found percent error.
I'm pretty sure that will be on there. Want me to do that problem that a lot of you guys asked me for the solution for, on the old exam that I posted? You guys remember that problem with the partials?
Yeah.
I'll go over that. Because this problem could be there for, 2 or 3. Well, it might be there for like 5 points or something. Okay. So any questions on this? This was exam 1, problem 4. Yeah. Okay.
You said, are you done writing that one?
Yeah, I'm going to the one with the percent. Okay. So we were given a surface area of an open top rectangle box with the formula. So this is 11. I have no idea what old exam this was on. Which one?
I think it was 3. It's either 3 or 4.
This was 11 on an old exam, like 3 or 4, you said?
Yeah.
Okay. I don't remember which one, but we'll just keep going. Given the surface area of an open top rectangle box, we have S is equal to B squared plus 4BH, where length and width are B. Use differentials to approximate the percent error and the calculated surface area B and H can be measured within plus, so B and H, we can measure them between plus minus 2% as their actual value, okay? So the first thing that they ask for is partial of S with respect to B. And what would that be? 2B plus 4H. We have to find partial of S with respect to H. What would that be? 4B. So
What is it that you wrote in parentheses at the top right?
length is equal to width, and that's equal to B. So knowing that base and height can be measured within plus minus 2%, we should know that the derivative of B with respect to B was equal to plus or minus 0.02. And that's also equal to dH over H. That's something you needed to understand from that. So ds was equal to, what did it do? So ds was equal to this ds plus this ds, right? Okay. Overall, so we have to find the percent error in the surface area, okay? And that would be ds over s. But if we are, so we can write an equation ds equal to this partial of s, and this was with, so this notation might be off, with b plus this partial of s with h, okay? But we have to,
Is that?
Oh, I think you do.
but we have to multiply this to this side and this to this side in order to have this ds plus this ds equal the entire differential as a whole.
What is it? Is this a practice exam or actual?
This was an old exam problem that I posted.
Okay, let me look.
So we have to find the, what do you call it? The change in S as a whole, right? We have equations for partial of S with divided by partial of D, and we have equations partial of S divided by partial of H, okay? But we need to add the partial of S's in order to find the total change in S. So we can do 2B plus 4H, but we need to multiply that by partial of B plus 4B, but we need to multiply that partial of H. So then we can add the two partials to get the change as a whole of the surface area. Did that make sense? first, so they asked us for these values on the top, right? They, so we found them, but but for us to find the change in S as a whole, we need to add the 4 components, or the 2 components, okay? Here and this is something that you need to know, that percent error is equal to, so dB over B is equal to 0.02, right? So then dB is equal to 0.02 times B, and then dH is equal to 0.02 times dH. Okay? So in that first equation, or this equation here, we can make the substitutions. So this is equal to 2b plus 4h times now plus or minus 0.02b plus 4b times plus or minus 0.02h. Okay? We substituted these values for these values. Okay? Now it's simplifying this. So this is equal to, we can multiply b across here, b across there, and they all will be multiplied by plus. So let me do that slowly. So we will have 0.02 plus or minus times 4b squared plus, 2b squared. 2b squared plus 4h, right? 4bh, or hb. Okay, so I just multiplied all of this by b, and for this plus, I'm going to multiply by h, so 4bh times plus or minus 0.02. Okay, you guys still following?
Sure, not the most, but that's
Now let's try to follow. Or I'm gonna say it again then.
thanks.
So, do you guys understand this part? Essentially, knowing that dB over B is equal to 0.02 and dH over H is equal to 0.02, because that's the percent error, we can find dB and we can find dH. The entire derivative, or ds, is equal to the partial of s that we found with the base and the partial of s that we found with h. Okay? So we need to add those components. But we found partial of s with respect to partial of b. In order to get partial of s alone, we need to multiply 2b plus 4h by partial of b. Okay? To get ds with h alone, we need to multiply 4b by partial of h. Okay? We know those values that we found before here. Partial of b, they should be partial sums. Or essentially, since b and h aren't in terms of other variables, they can be partial or just full on d, but that's the same thing as partial of b. That's the same thing as partial of h. So then we make those substitutions. So 2b plus 4h times the quantity of plus or minus 0.02b plus 4b times the quantity of plus or minus 0.02h. Okay? Then we just try to simplify this.
0.02H, right? Not 0.02H. Or what is that?
On the left side.
Are you talking about here?
Yes, what's that?
That's 0.02 times the h. Yeah, sorry. Good hit. Because we brought the h to the other side. Okay. So we can simplify this part even more. We can take out a 2 from all of them. We can take out a plus or minus 0.02 from both of them. So we have plus or minus 0.04, because they all can be, they all have an additional 2 being multiplied to them, times the quantity of b squared plus 2hb plus 2bh. So that comes from this part, this comes from that part. Okay? Does that make sense? Just a little algebra there. I took out 2 from this to make that a plus or minus 0.04, a 2 from this to make it a plus or minus 4, then factored it out from both of them. Okay. So then this is equal to b squared plus 4bh. Okay. B squared plus 4bh. What is that equal to? That is equal to x.
Oh, look what we did.
So then
What is that?
we have ds equal to plus or minus 0.04 times s.
What did you guys put in?
We want ds over s because we want to know the percent error that the surface area can be approximated with. We divide by an s. So then our answer is plus or minus 0.04 or 4%. So this was a tricky problem, but you have to deal with it. So any questions on this problem? You can see the picture. Again, the strategy with the final and all like exams is always, if you really get stuck on a problem, don't waste your time on it. Keep going, finish the exam, and then go back. That's essentially what I did for most of calculus. And in the end, most of the exams you do have enough time, but yeah.
Where do you post your exams at?
So on Blackboard, so they should all be posted there. So I can show you.
It's in the SI section.
It's in the,
Not
so
to be under the calc class itself.
you go to Reach, there's a box for Reach on Blackboard, then you click the organization for engineering fundamentals, and you'll see my name. And I can show you later. So this video will be posted there too. So any questions on that problem? Because I don't know if they'll actually test you on it, but it's good to know it in case they do, because it was a really small topic. You guys learned linearization as well in Calc 3, right?
We did.
Yeah, we never used it.
You never use it on exam? I would still look at that. That's just one of those random topics that they might put in. Otherwise, most of the, see, there's a lot of problems I could cover, but essentially that's just me writing down stuff because it's like the formula for flux or stuff like that. So unless you guys have one of those right now, that's the end of the session. That formula, that's not in one of the reviews, I believe. Yeah. But yeah, so you'll definitely have a question on sketching a solid. I feel like the way I thought of that is just I made one of the coordinates 0 and tried to imagine it in a 2D figure, and that's how I explained it to you guys, and then sort of tried to connect all the edges. but definitely practice those. And once you see like 2 or 3 different examples, you sort of can draw it in most problems. So any other questions overall on Calc 3? Yeah.
Well, we have to convert between the different coordinate systems.
Yeah.
Would that be a specific problem though, like convert?
No, I doubt it'll be a specific problem. You might be given a problem where it's like use the most optimum coordinate system, and then some of the stuff will have like x squared plus y squared plus z squared or something, and then you have to use rho squared. So then spherical might be the best method. So then conversion like that, essentially. Is that it, guys? Thanks for coming. It's been a great year.
Aw.
Yep.